Alright, so here's one of the classic physics examples of unbalanced forces and the result of them. So this is a hypothetical, and actually we do have them in real life. We use them in certain places, but it's called an Atwood machine. And what it is it's a pulley with, and ideally it's a low friction pulley, but a pulley with two different masses, close in mass, one slightly smaller, one slightly larger. So you'll see my 10 kilogram mass is slightly less than my 11 kilogram mass. Now, this example, if you look at like this YouTube, you'll see your heavier mass down below and your lighter mass hanging up top. And when they're released, it causes the system to accelerate. So the mass that's heavier pulls down harder than the mass that's lighter, causing this to move. And so for our purposes, we're going to use this as a way to look at forces and free body diagrams. Well, right away, if we're trying to make force or free body diagrams, we have to realize a couple things. So I'm going to rely on this pre-made one for us. Regardless of the masses, okay, you're going to have a bigger and a smaller mass in an Atwood machine. If they're the same, it's not going to move, and it's going to be a pretty boring one. But that said, you have your forces of gravity that are going to be different on these two. Okay, so obviously the larger mass has the larger force of gravity. The smaller mass has the lesser force of gravity. And so if we look at this, we know that this thing is going to accelerate down, which means this object is going to accelerate upward. But if you do the force diagrams of each of these individually, mass, force of gravity down, force of tension up, force of gravity down, force of tension up. And we know that these two forces of tension are going to be exactly the same. It's the same string. Now, the hard part, I guess, comes when we're trying to figure out our unbalanced force. But if I actually have you conceptualize this slightly differently, and if I take both of these forces, if this is mass 2 and if this is mass 1, we know that this is bigger than that, but if we look at it and conceptualize it as though it's on a flat surface, finding the unbalanced force becomes a little bit easier. So I have my force of gravity of mass 1 and my force of gravity of mass 2. Well, now you can see I have a tug of war. This one's going to win, and so my unbalanced force is going to be my force of gravity 1 minus my force of gravity 2. Okay? If we apply that to Fu is equal to ma, we would have to actually consider the whole mass of the system. We'll show you what I mean up top here. So if we do this with the numbers we're given, mass 2 is 11 kilograms, mass 1 is 10 kilograms, that means the force of gravity of mass 2 is going to be equal to 107.8 newtons, and that means mass 1, force of gravity, is going to be 98 newtons. Now, for the sake of this, if we're asked to say, find the acceleration, okay, well, we first have to find our unbalanced force. And so like we were talking down below here, we just have to take the difference of our forces of gravity, because if you conceptualize it in this way, your force of tension really doesn't matter. It cancels. Okay? So if we're looking at this and we want to find the acceleration, we first have to find the unbalanced force by taking our force of gravity, which is our larger one from mass 2, 107.8, minus 98. You should get an unbalanced force of 9.8 newtons. Okay, so that is our unbalanced force. Now we want to take this and we can use Newton's second law again, Fu is equal to ma, to solve for that. Here's the trick though. When we're taking the overall unbalanced force and applying it to the overall system, this has to be the total mass. So it can't be just one or the other. It's the total mass of the whole system to find the acceleration. So my unbalanced force is 9.8 newtons we just found here. Okay? Our mass is going to be 10 plus 11 times 8. 10 for the smaller mass, 11 for the larger mass. So 9.8 ends up being equal to 21a. So if I divide both sides by 21, I get 0.47 meters per second squared. Okay, so that's the first question that we could answer about a situation like this. Now the other one, and a little bit more tricky, is if I'm asked to say, find the force of tension. So if I want to do that, if I want to find the force of tension, Okay? It's easiest to then take this and consider your force diagrams as individual objects. I'll show you what I mean. So I know this is larger than that, and I know this is smaller than that. But if I say use mass 1 to find my force of tension, okay, I know the force of gravity of mass 1 is going to be 98 newtons. I know the force of tension up is going to be larger than that 98 newtons. Okay, so if I want to figure out how much larger, I have to figure out my unbalanced force for mass 1. So Fu is equal to ma. Well, we just did all that work to solve for the acceleration of the system. Now if I'm just considering one mass or the other, I can find the tension using it. Let me show you how. So I know my acceleration is 0.47. I know my mass is 10. So my unbalanced force here is going to be mass 10 times my acceleration of 0.47. So my unbalanced force here is going to be 0.47 times 10, 4.7 newtons. Okay, so that means that my force of tension is 4.7 larger than my force of gravity. So my force of tension then is going to be 98 plus 4.7. So that becomes 102.7. And so that then makes our unbalanced force true, this being 4.7 larger than that. So the other way that you could do it is you could consider the larger mass. So again, we'll show you what that looks like. If we go back to here, we know that this force of gravity is going to be larger than the tension up. So if I do this for mass 2 now, okay, so we'll consider mass 2. Force diagram applies. Again, remember, force of gravity on this one is larger than the force of tension. Okay, and so we had the force of gravity to be 107.8. And I know this time my unbalanced force is going to be that way. This is going to be larger than my force of tension based off of how we know it's going to move. But that said, we still have our acceleration and we still have our mass. So I have an 11 kilogram mass and my acceleration is 0.47. And so 11 times 0.47 now is going to give me 5.17. So my unbalanced force downward is 5.17 newtons. So that means this is 5.17 larger than my force of tension. So if I'm to find my force of tension, and we'll really round this to 5.2 to keep our rounding consistent, but if I find my force of tension, knowing that my unbalanced force is 5.2 this way, that means my force of tension has to be 107.8 minus 5.2, which we end up with 98.6. What is that? Let me quick punch it in. Gets me 102.6, excuse me. And so you'll notice then, there is a slight difference between here, and that's completely and totally rounding. If I used enough variables or enough places after the decimal, they'll be totally equal, which they are. But that said, finding the force of tension is a little bit tricky, but that is just another application of Newton's second law, Fu is equal to ma. That's the Atwood machine. Brief introduction. Hopefully that helps with your homework.